Hi, welcome back. In this section, we are going to discuss about different methods to split arrays in NumPy. For that, we need to import the NumPy library using the command import NumPy as NP. First, we will discuss about one-dimensional array splitting. So for that, I created a one-dimensional array which start from 1 to 18. Then if you want to split this array into two equal parts, so the command is np.split. It's very straightforward. Open the parenthesis, and inside the parenthesis we will give the numpy array x comma how many parts we want to divide it into. Suppose I want to divide it into two parts, so I just put 2, enter 2. So we got two arrays which was equally divided. That means 1 to 9, the half of the elements are in the first array and the second half of the elements in the second array. Suppose I want to divide it into three parts. So np.split, open the parenthesis and give the input x and 3, how many parts we want to divide. So here it is 3 parts. The first is 1 to 6 and the second array contain the second part, that is 7 to 12. Then the third array contain 13 to 18, that is divided into 3 parts. Suppose I want to divide it into a custom like split. That means I suppose instead of equal parts I want to divide 1 to 4 is a separate array. Then I want to divide 5 to 11 in a separate array and 12 to 18 in a third array. So that is custom split. So how to do that? How to divide it into in custom method? So that is again the same command np.split. Sorry, np.split. Open the parenthesis, give the numpy array which we want to split and the positions. And one more thing, it is different from the actual positioning method in Python. The positions we will give in bracket, square bracket. That means the position we will not start from 0. Normally in Python, this is 0th position, this is 1 position, second position, third. But in this concept, in this split concept, we will start from count from 1, not from 0. So if you want to split up to 4, then we will give 1, 2, 3, 4, that fourth position 4. Then suppose I want to split from 9 or I want to split from 6. So 1, 2, 3, 4, 5, 6. So I give 6. Now I want to split from 10. So 1, 2, 3, 4, 5 up to the position is 10. So I give 10. Again I want to split from 13. So again 1, 2, 3 up to 13. So position is 13. If you run this, we can see the first 4 digit was in a first array, and from up to 6th position, that is in the second array from there, 5 and 6, then up to 10. So after 6, 7 to 10 in a third array, and then up to 13, 11 to 13. Remaining everything will be in the last array. So this is a custom split. Again, we can create a different array and check how it works. Instead of 1, 2, 3, suppose I am creating a different array with the index 3. So I got 1, 4, 7, 10, and 16. So again, I'm doing custom split. So np dot split, open the parenthesis x, we input the array. Then the position we are giving in list. That means suppose I want to split from 7. So 7 is in which position? 1, 2, and 3. So 3. And then suppose I want to split from 13. So 13 is 1, 2, 3, 4, and 5. 13 is 5. So if I'm doing running this command, I'll get 1 to 7 in for the first up to 3, it is in one array. Then the second is up to which position? Fifth position up to here. Then remaining is in the third array. And also one thing we need to keep in mind, the position or the counting of the position not start from 0. Here it is starting from 1, 1, 2, 3. But in standard Python and all the commands is normally start from 0. But here there is an exception. And suppose in this command we divided all the arrays. Now how to access this element? Suppose I want to access only this array or the second array or the third array, anything. So how to access that? Again, we will just copy the first command, that is npx, the previous array we created, and now we are dividing that into equal parts sum. So just copy this command and dividing it into equal parts. Suppose not 3, instead of I'll run 4. Sorry. Sorry, 3. Really. I divide it into three comments, three equal parts. Now I want to access any one of the array. That means I want to access this array, 17, 7, 8, 9. So what is the position in this actually? This is 0th position, first element, and this is the second. So the position is, again, I will split this, copy, split, then open the square bracket and put the position, that is 1. So I will get this array, the second array. Suppose I want to get the third array, this array, the last array. So the command is, again, split it. First we will split that and then give the position of that. Position is what? It is 2. So we'll give the position 2. Again, to access this last element, we can use one more method, reverse indexing. Currently, we are using forward indexing method. We can use reverse indexing. That means from here to up, that is -1, this is -2, and this is, the top one is -3. So if you are forward indexing from top to bottom, it is 0, 1, and 0th position, and this is first position, this is second position. So for reverse indexing, I'm using np.split x into 3 parts. Now I am using reverse indexing. Next, we will be discussing about unequal splitting of arrays. For that, we created a NumPy array with elements 1 to 10. It has 10 elements, and we tried to split that into 3 equal parts using the command np.split x comma 3. So that will throws an error, because as we know, 10 cannot be equally divided into 3 parts. Always there will be one remainder. So in that case, we can use a different command, that is np.array underscore split and x comma 3. So that will give an output, but definitely, yes, it is not equally divided, but at least it gives a proper output. So in that case, the first array, it will added 4 elements, and in the second array it added 3 elements, and the third array it added another 3 elements. So let's have a look how actually this works. Suppose this is the array we created now, 1 to 10, and we are trying to divide it into 3 equal parts. So what it does, first it will divide it into 3, divided by 3. So it will get 3, 3 up to 9, the highest number which can be equally divided into 3. And it will take the remainder of the division, that is 1. Then what it does, it add that remainder or that one element to the first row. Actually, this is not the element. This is actually the placeholders. Placeholders means the elements. There are 10 elements, so it has 10 placeholders, and the remaining placeholder it will add to the first array. Now the splitted array become, first is 4, then 3, then another. The third one is also 3. Now we will add the elements to that. That is the first 1, 2, 3, and 4 here. Then the next 5, 6, 7. The 3 elements are here, and the 3 elements are in the last row. Similarly, suppose we have 11 elements there and we want to divide that into 3. The same condition is divided, it divided by 3. So we have 9 here and 2 placeholders are remaining. So what it does, first it adds the first placeholder to the first array and it adds the second placeholder to the second array. Then it has a new order of placeholder. That is, the first have 4 elements, then the next array have 4 elements, and the next have 3 elements. So now we will add the element, that is 1, 2, 3, 4. The first 4 elements in this placeholder, and the next 4 elements will be in this placeholder, and the next 3 elements will be in this placeholder. So we will just have a look the same we can try here. So I'm just again creating a NumPy array here with 11 elements. So if I'm putting 12, so I got a NumPy array 1 to 11. Now I'm trying to use the command np dot array underscore split, open the parenthesis, and giving the variable x or the array x and divide it into 3. So the output will be, we can see the first group or the first array have 4 placeholders or 4 elements, and the second array also the 4 elements, and the third array have 3 elements. So this is all about the one-dimensional array splitting, the basic concepts. Now we will be discussing about two-dimensional array splittings.